1T8S 1T8S OK 好。1T8S OK 好 link 咧就啱啱 send 咗喺 chat box 嗰度，咁大家可以過去啦 ，say 個 hi。我喺 WhatsApp 都放一放先，留翻個底。2同埋16未見到，都係。好 YouTube 試音啊，咁 Google Meet 未瞄，瞄咗先啦，都一陣再點名啦。好 YouTube 試音啊，有冇聲？有冇聲？好 YouTube 試音啊，有冇聲？有冇聲 ？YouTube 試音啊，有冇聲？有冇聲 ？Okay, so after you have arrived here, please say hi in the chat box. Two and 16, okay. This is about chapter 8, more quadratic equation. And we will continue from last at the very beginning, and then have a very quick review, and then we will move to the last section. Then, as I mentioned earlier, there is a section that I would like you to try by yourself. I will first briefly talk about this here, and then you go to the worksheet by yourself and do self-study. Okay, so by the way, I make the chat box. Oh, okay, chat box. So see if there's any problem for the chat box. So is the chat box okay now? After you have arrived here, please say hi in the chat box. Oh, the testing, okay, testing comes out. Okay, then I change to the textbook section first. iPad and the cover photo. Okay, sound okay. Thank you, John. Thank you. Okay, so we first begin with a short section for our review of last time. Last time that in fact the last time was in fact quite very long time ago, because before that we have some review on MC test. That is before we 大聲少少啊 ，OK 好，大聲少少睇先，係啲。呢個應該唔關事。好 ，OK， 咁我大聲啲啦，咁真係用講嘢大聲啲啦。OK， 好。Before that we have some MC test review, and then therefore we have been away from this chapter 8 for quite some time. And so before that we were talking about how to solve equations like this. That means one quadratic and one linear probably, and then and two equations with two unknowns x and y, but one may be quadratic, one linear, or in the middle one quadratic, one linear. And then we try to do some substitution, put the y equal to negative x minus 4, and then put everything in here, and then becomes a simple quadratic equation, and to solve to use the formula 0, 1 to solve it. Alright, so that was before. And then here before we go to the next one, we also see some meaning in the graph. What does it mean when we put two equations together and then to solve it? Of course, when we want to solve it, then we want to find the x and y for solution. That means that will make both equations correct. But then what about if we are referring to the graph? We all know that a quadratic equation graph will be a parabola, and also a linear equation graph will be a straight line. Therefore, when we talk about when we put them together and solve it, and then what does it mean? What the meaning? And therefore, we briefly talk about this, and then we can go to the next session. So when we put these two together, then it means that this graph is a parabola. Okay, I put some more remark here. Then this is a parabola. Is the words clear in the screen? Oh, okay, maybe I can make it bigger. I try to make the lines more thick. So the quadratic one will be a parabola. And then the other one is in the form of y equal to mx plus c. Therefore, it is a straight line. Alright then, so when we put these two together and solve it, then in fact we want to find those x, y that makes the equation 1 correct. That is the parabola. Also, we want to find that makes the equation 2 correct. That is the straight line. And therefore, it means we want to find the points that are on the parabola and also on the straight line. If it is on the parabola and on the straight line, then the easy result will be that we want to find their intersection point. Therefore, when we put them together, it is that we want to find the intersection point. And then in this the graph that follows, that means the picture here, then the intersection point will be this point and this point. And therefore, if we are to understand the meaning in the graph, then this would be when we put these two together with a curly bracket like this, when we put these together, then it means we want to find the intersection point. And then the intersection point here would be the meeting point of the two graphs. So that is also the meaning after we found the x equal to something, y equal to something, the meaning is that it is in fact the intersection point of the two graphs. That is the parabola and the straight line. And that is also why in the last section, the textbook tried to suggest the answer in maybe further. In the last section, the textbooks try to suggest the answer with coordinates, because that is also the meaning, the intersection point. Okay, so now this is the idea for that part. I would like you to have more study by yourself. This is the section 8.2. And I briefly talk about this. When we put equations together, then it means we find intersection points. Okay? And then so afterwards, then a very quick example or view, then we will go on to the last section for we do more solving, more different kinds of equation. So I think some special ones may be, for example, just briefly this one, the example 9, a very brief one. And you can see here the parabola and the straight line does not meet because there is a distance between them, a very small distance between them. Then this parabola and the straight line does not meet. And therefore, but putting the equations together means to find intersection point, but they do not meet, therefore no solution. Okay, so it can also be the case that there is no solution. And then talking about more illustrative example would then be sometimes there's no graph given, but then it is described in words. Okay, so words are given, described in words, and then for example, for the example 10, the quadratic curve y equal to x squared minus x plus k touches. Okay, keyword here. Maybe you can highlight by yourself also later when you see questions. Okay, you can highlight this by yourself. Touches. Okay, so touches the line y equal to 2x minus 1. So it's a parabola. Touches the straight line at one point P. Of course, when it is touch, that means it just touch means it just one another one contact at just one point. For example, parabola and a straight line. Then this is a touch. If you study M2, then you may understand more. This is the meaning of the tangent. Okay, touch. So I touch the line. Parabola touch the line. And then so this is the at one point. Since it is touched, then of course it is only one point. Okay, then we want to do some finding unknowns. So Why is it so? Because in the parabola there is an unknown. In the parabola there is an unknown k, and the straight line is OK, all are given. And then the touching point is p. So if we want to find the value of k, then we can focus on the touch keyword, the keyword touch. Again, same as before, put the two equations together to find intersection point. Put the two equations together and do some solving as usual. However, we cannot really solve it because there is an unknown k. But then we can make use the meaning for touch. Touch means only one solution. Touch means only one solution. Therefore, after we do some solving, eliminate the y, and then we will have a quadratic equation. And quadratic equation usually has two solutions. But now here, then it is only one solution for touch. Therefore, it is a special quadratic equation. That means a quadratic equation with that does not have two solutions. And so a quadratic equation that has only one solution, then it refers to delta equal to 0. And then with this quadratic equation and delta equal to 0, then we can really find the k. And then there are more steps on the next page, so we briefly see it. So delta equal to 0, and then going on, check the delta b squared minus 4ac. In case it was a too long time ago and you have forgotten it, then we can really find the k. So that is the skill when we use this. Okay, so this is the skill when we use when there are some unknown and we use the touch property. So this is the main example I would like to share this with you. And while this part, I would really like you to go to the worksheet and do some questions by yourself. So here I briefly show the worksheet. This is the 8.2 worksheet. Then the summary is also here. By putting two equations together and do some solving, and then check the delta for different cases. For example, just the last example, delta equal to 0 corresponds to the touch case. The touch case, that means the parabola, touch, and the straight line just touch each other. Only one intersection point. And of course, then the other one, delta bigger than 0, two solutions. So two intersections. And delta less than 0, that means no solution. So no cutting at all, no intersection at all. And then I would like you, for example, in the afternoon or other times, then try these questions by yourself. Okay, so just a few here. Try these questions by yourself. Okay, then this would be the 8.2. And then now we take the time and then go on to the 8.3, which is the last section, talking about more different kinds of quadratic equations. That is also like in our title of this live. So more kinds of quadratic equation, 8.3. So so far, any questions for the last part, 8.2? So tell me something if there are some questions or there are no problems. Tell me something in the chat box. No problem, or okay, or some questions don't understand, just tell. So just say it, everyone. Okay, just everyone try to say something. So is it okay? Or is there any questions for the last part? That is about putting equations together means finding intersection points. Putting equations together means finding intersection points. And then we can use, for example, since it is quadratic, we use delta to help us. Okay. 咦，真係唔見佢哋喎，真係唔見佢哋喎，嗰半堂有多咯喎。OK， 咁可能佢真係請假 absent 嗰啲。Okay, so okay, thank you. So that's good that at least I see some okays. Then the next section, 8.3, as you can see on the screen here, is about equations reducible to quadratic equations. That is, you will see we are seeing a lot more different kinds of example or different types of example, which means you may see not just exactly a quadratic equation, but then other different forms. But all these forms we can change it back to quadratic. That's why it is called reducible to quadratic. So the original equation may not be quadratic equation or we may not easily see it as a quadratic equation. But after doing some changes, we can really change it back to quadratic equation. And therefore, so this is we are going to study different kinds. There are different kinds of it. Altogether, if I don't remember wrong, there are 5 types. But we don't really need to remember all those 5 types because usually when we see the equation, then we will try to make it. We will simplify the equation and then try our best to make it quadratic if possible. So let's see some examples. The first kind is about fraction. Sometimes the equation may involve fraction. But then after doing some changes, after doing some rearrangements, then we can make it into a quadratic equation. And very, very often, whenever it is about fraction, then we always try to do something is to make common denominator. Oh, so okay, maybe I really make this more thicker. Seems difficult to see in the screen. So when it is a fraction equation, then we always try to make common denominator. If it is plus or minus， 如果我哋做分數加減，通常都會通一通分母啊。So if we see fraction, then very often what we do is to make common denominator if it is plus or minus. Of course, if it is times, then we don't need to do this. If it is times, we don't need to do. For example, if it is 1/2 times 3/5, then we don't need to make the common denominator. We just need to multiply upper part and the lower part. Just multiply the numerator and denominator one by one. But we don't need to do it. Really, don't try to do it. Don't try to make common denominator. It wastes time. Okay. Don't try to do this. Okay. Don't try to do this. It wastes time. For times and divide, no need. But we always do common denominator if it is plus or minus. Okay, so we see some example. Examples are with solutions are in the book. Therefore, we try to see quick practice. So the quick practice 11. I hope I can do maybe like 2 or 3 questions. Because we have about like 10 plus 8, about 18 minutes. So before it ends, and so we hope to have a few examples, 2 or 3. So quick practice. This one you see the equation with some fractions. There is the upper part, lower part, and then also combined with some simple multiplication. And therefore, to handle this, we first see the inside. This inside is a 1 minus something, and then there is a denominator then, and also we always don't want to see the denominator in equation. Whenever there is a denominator, then we always try to remove the denominator using different ways. And what's more is you can see here it is a 1 minus a fraction, and therefore usual multiplication may not just work, but it will be better if we make the common denominator first. Common denominator. That means here 1 minus this one, we simplify this bracket first, and then next we try to remove the denominator. So to begin with, then we try to make a common denominator for this one. For this whole thing, the big bracket here. And if we try to make a common denominator, this is originally 1. 1 means no denominator. And so no denominator, but make it into x plus 3 denominator, then the upper part will also make x plus 3. So that this thing, when simplified, it will become 1. Or when we make the denominator 1 become this thing. And then the other one will be minus 2. So minus 2. And then the outside, just copy. So when we do the steps, we just change one thing and the others keep the same. Alright, so this is the common denominator. This is also the part I highlighted here. We always do make common denominator. Okay, so this we are exactly doing the same thing here. So make common denominator. Then the upper part we can do some simplification. X plus 3 minus 2, therefore it becomes x plus 1, and then over x plus 3, and then times 6 plus x equals to -4. And then just as the beginning I said, we always don't like denominator in equation. Therefore, the next we will try to do is to remove the denominator. So why we make common denominator first? Because we can remove it easier. And therefore, so we try to remove this denominator. And we can do remove denominator by moving it to the other side, multiply. Because this is a divide and then multiply, their order does not really matter, and therefore we can remove this to the other side. Okay, so the next will be we try to remove this to the by multiply to the other side, and that means that then the left hand side becomes x plus 1 and then 6 plus x, while the right hand side becomes -4x plus 3. And then from now on it becomes a quadratic equation because you can see no more denominator. And then this one we can expand it and get power 2, and this one expand it, we can also get some terms, then it becomes quadratic. And now then you can go on and solve. And by the way, I just see Lauren is in Google Meet, therefore I take the roll call first, and now you take some time and finish this one. Okay, after reaching the step like quadratic, then we take this step. 好攞俾我調翻你名先啊。OK， 咁就 Google Meet 嗰個 link 咧就係喺WhatsApp 同埋喺 WhatsApp 度見到㗎啦，咁你可以過翻去。Okay, so I also show some work here. Expand x squared and then 7x. So if you are familiar with the expansion, then you can directly write the result. And also it's better when you do more, be more familiar. When you do more, get yourself more familiar and just you can expand it in one step. For example, how this 7 comes, it is 6x and 1x. Then move everything to one side so that we can press calculator. And this one we can press calculator, or if you are good at mental calculation, then you can also see 11, 9 times 2. Therefore 9 plus 2, 9 times 2. Then answer. Okay, so this is the solving, and you can see this original equation is a fraction and also seems not easy to handle, but then afterwards we can do it. We can make the common denominator and multiply the denominator to the other side, then we can make it quadratic, and that's also why we call it equations reducible to quadratic equation. That's also why we say this equation we can reduce it to quadratic equation and call reducible to quadratic equation. So this is example 1. Let's make the best of our time and do one more, the other one. So also some fraction equation for quick practice 12. Some fraction equation. And then now this time maybe we do part A first, while part B probably as a self work. So the quick practice 12 part A here, you can see again equation with fractions, and then here the denominator we got x squared minus 1, and the other denominator is x plus 1, and therefore again using by the way also they are doing a subtraction, fraction minus fraction. Then our usual way to do it will be to make common denominator. When a fraction minus fraction, make common denominator. And then so when we make common denominator for these two, then we can make use more we have just learned in, not just learned, we learned in chapter 5. Make common denominator, then we can, you know what I'm going to talk about, make common denominator, then we can do, in chapter 5 we learn about the LCM. Right, so we can try to use the LCM to be the denominator, to be the common denominator. And so for LCM, this is about then this is if you are more familiar with it, then you will find this easier. So if we are to do LCM, then it's x squared minus 1. We can factorize it. Okay, for example, maybe I make it purple in color. If we do x squared minus 1, then we can factorize it and become x plus 1 bracket x minus 1. And if we factorize it like this, then the LCM can be more easier to see. Because x plus 1, we both have it here, so we don't need to make more. It's just that this first one, the purple one, got x minus 1, and the second one does not have. Therefore, we need to have the x minus 1 for the second one, and to make the LCM and make the common denominator. Okay, therefore, so the whole idea will be like this. We do this part A first. Then we can change it to 1 over x plus 1, x minus 1. And then minus 4 over x plus 1. The right hand side is negative 1. And then next we try to make the common denominator. Okay, that means the LCM. So LCM also circle in blue. So we try to make the LCM of these two. Because when we do common denominator, LCM is the simplest. And so the LCM will then be just put both have x plus 1, and then one has x minus 1, the other does not have. Therefore, the LCM will be just to include everything. And then the first one is okay because the first one is already exactly the same as the denominator, while we need to do more for the second one. So the first one, okay, just put it. While the second one is minus 4. But then this second term does not has x minus 1, therefore we need to make it by ourselves, and therefore it will be x minus 1 added to the second term. And also, okay, the next, by the way, when we do this add the x minus 1, remember to get a bracket for it, because we are doing it for both numerator and denominator. This x plus 1 become the new denominator. Then 4 also remember to have a bracket because it's multiplied for the whole numerator. And then the other side equal to negative 1. Okay, then again the same usual step. After common denominator, then we move the denominator by multiply to the right hand side. Okay, so we can do this all in the same step, then move to the other side. While the upper one, we can also do some simplification. That is a 1 minus 4x plus 4. Be careful about this 4. This plus 4. Minus, then become plus. Okay, be careful when we do expansions like this. And then going on, you see now this is a quadratic equation. The left hand side is some terms with x and number. The right hand side, when we expand it, it becomes power 2. And therefore, so we can solve it. Again, just give you some time to solve it by yourself. And at the same time, I try to show on the screen. But I do not explain so much. Okay, that's it. Any questions? If you have already finished, refer to the screen and see, is it okay? So then finally we treasure our time, about 5 minutes left, and talk about one more kind. Okay, so about 5 minutes left, we talk about the other kind. Also not a very difficult one. The more complicated one are for the third and the fourth and fifth. Okay, and then so the other kind will be about higher degree equation. So maybe we can see one example from about higher degree. Very often, so if we are to make it into quadratic, then we will try to recognize some key steps, some key features. Okay, by the way, I try to reply to the office first. Okay, so higher degree. So how will it be higher degree change to quadratic? Then we try to recognize some special feature from the equation. Now I try to highlight the feature in example, but then we do some real work in the quick practice. I highlight the feature. How is it? So the idea is we try to recognize. Sorry. Oh, don't know how to spell. Recognize a double power. What does it mean? What does it mean to find some double power? Then just see here. We have x power 4 and x power 2. The meaning, but when I mean double power, it means that you recognize this power 4 and power 2. It is a double. The same idea for the other part. We have x power 6 and x power 3. Then the idea here is to recognize the double power. So if you can recognize the double power, then just let the no double to be u. So first recognize the double power and then let u be the one with no double. That is here. If it is x power 4 and x power 2, it is a double power. Then we let u to be the one that is not double. Then we let u for the x square. On the other hand, for part B, we see the x power 6 and x power 3. Then 6 is a double power of 3. Then we just let u to be the single power. Okay, maybe I say single power, it will be easier to understand. So we try to do some real work in the quick practice. We try to do some real work in the quick practice. Again, when you see equations like this, x power 4 and then 3x squared minus 4 equal to 0, then you try to recognize, is there a double power, x power 4 and x power 2? And you can see 4 is a double of 2. And therefore, we try to let this whole x squared to be u. And see if we can do more. Why is the double power important? Because when it is a double power, it means double means times 2. If the power is times 2, then if we let u to be the single power, what will be the double power term? Then x power 4 will then be x power 2 and then times 2. It's the index law. Because double power, then this 4 will be the double of the x squared. And that means it can change to u squared. And therefore, all in all, this whole equation can then be made into u squared plus 3u minus 4 equal to 0. And then we can make it, it is already in the quadratic and we can use calculator, get the answer easily. And so next it will be u present calculator, u equal to -4 or u equal to 1. Of course, u is the unknown we introduced. Therefore, we want to find x and change it back to x. But u is the x square when we let. Okay. Therefore, it is a x square equal to -4 or x square equal to 1. And then finally, by taking the square root, we can get the answer. If we do square roots, then this will be square root of negative number, that means I. So x will be positive or -2i, or x will be equal to positive or -1. Remember to take, when we take square roots, we add positive, negative. And this is the part A. Okay, so but I see the time is already up. Therefore, we go on next time. We go on tomorrow. Tomorrow, we have lesson 6. We have lesson 6 in the morning. Okay, so that's it. So let's see you tomorrow. Goodbye.